In this video, we're going to use triple integral in spherical coordinates to work out this volume here, V. So V is really the half of the big sphere, half of this big sphere here, take away the volume of a small sphere. So take away the volume of the small sphere. So the small sphere has a radius of 1. The big sphere has the radius of 2. So our job is to work out V. But before I can tell you about the equation of the small sphere in spherical coordinates, I need to give you a reminder of a 2D circle in polar coordinates. Then that will help me to explain this equation of a sphere in 3D. Okay, so revision time now. A circle of radius 1, the equation of this circle here is given by this in Cartesian form. To convert into polar form, so remember this is revision, so you should know this by now. We would put this into here, we would put this into here, that will then give us this. Multiply this out, that will then give us this. That will then give us this whole thing here. These two cancel each other out, and then you can factorize out the r squared here. And then this thing here becomes 1. So blah blah blah, r equals this. What I'm trying to say here is that in 2D, if you plot this graph, r versus theta, so you're in 2D you're scanning like this from an angle of 0 to an angle of pi. So you're scanning along like this. So from 0 to pi. So you're only interested in this region here. You ignore this bit here. So you're moving around like this. So by the time you get to pi over 2, which is here, the radius will be 2. That's why by the time you get to 90 degrees, the radius will be 2. And then the radius decreases. And then by the time you get to an angle of pi, the radius would be 0. That's why there is no radius when you get to pi. So this is a revision. You should know this by now. So now let's move to 3D now. So in 3D, a sphere is given by this, and then if you want to move the sphere up by 1 in the z direction, then you would replace this with z minus 1. So the equation of a sphere that's been shifted up by 1 in the z direction is given by this in Cartesian form. So now convert it into spherical form. Remember, you must know this by now. So to convert into spherical form, let's just multiply this out first. So that will then give us this, and then the two ones here will cancel each other out. That will then take us to here. So now we can put x into here, and then when you square it, it becomes rho squared, and then you've got sine squared phi, and then you've got cos squared theta. So that's just x squared. That's just this thing here. So this thing here will then become this thing. And then y squared, you would put this whole block here into the y. That will then give us this whole thing here. And then z, you would put this into the z here. And then when you square it, it will then becomes this. And then you've got your minus 2, and then for z, have I made a mistake? Oh, no, I haven't. So z here, you would put this into the z here. That would then give you this. So from Cartesian form into spherical form would take you to here. And then, hang on, and then looking at this, this is in common with this, so you can factor out, well, you can merge these two together to give you this. Later on this will be 1. Okay, this will be 1 later on. That will then take you to here, and then this thing here is 1. So so this whole thing here will then become this. So we are currently here. Don't forget you add this to the other side, so that will then give you this. So we are currently here, and then looking at this, rho squared, so you can factor it out. So combining these two would then give you this. So, and then divide both sides by rho, and then that would take you to here. So what that means is this. Plot your graph of rho, which is the radius of the small sphere here. Plot this graph, an amplitude of 2. One cycle is 2 pi. So what that means is this. Rho represents your radius. So remember this when you're pointing like this, rho is this angle here. Phi is this angle here, remember. So when phi is at an angle of 0, it has a radius of 2. So that means so remember, you're scanning like this, you're scanning like this, you're scanning like this. So so phi is increasing all the time up to an angle of 90 degrees, which is pi over 2 up to here. So we are only interested in this angle here. Okay, we can ignore everything else. So let's start again. When phi is at an angle of 0, the radius of our small sphere is 2. So this is 2. So this is 2. And then as you increase it, let's say as you increase the angle, let's say we are currently here. So so this angle here corresponds to, let's just say this angle, let's just say it's phi here. So that would mean your radius gets smaller and smaller. So you can see the radius is getting smaller and smaller. So you can see that the radius is getting smaller and smaller. So hang on, let me illustrate it better. So you're moving along like this. You're moving along like this. So this dictates your radius. So hang on. So it's really describing that small sphere. As you increase the angle, it's describing the sphere. So so this small sphere here is given by this. This equation here alone would describe this sphere in spherical coordinates. So all you need to describe this sphere is this thing here. That's enough to describe this small sphere. I will continue in the next video. The next video would be us setting this up to work out the volume. Okay, I will continue in the next video.